Welcome to Essentials of the Earth Climate System. The book is written by Roger Berry, Eileen Hall McKean, and we start with the Chapter 5, General Circulation. This chapter will cover 4 parts: factors, meridional cells, and zonal winds belts, zonal circulations. We start to talk about our climate dynamics. The dynamic and thermodynamic processes that give rise to the large scale atmospheric circulation. Two factors, so there are two principal factors that determine the general circulation of the Earth's atmosphere. They are the latitudinal differences of energy received by the Earth's atmosphere system from the Sun, with an excess in the tropics and a deficit high in latitudes, and the corresponding global distribution of angular momentum of the atmosphere. And we will examine the two factors in turn later. So essentially 100% of energy that fuels the Earth comes from the Sun. To maintain a constant global average temperature, all of the Sun's radiation that enters Earth's atmosphere must eventually be sent back to space. This is achieved through Earth energy balance. So this figure depicts how the energy from the Sun is absorbed, reflected, and emitted by the Earth. So any object or gas that has a temperature emits radiation outward, and this is ultimately radiated back into space. This occurs 24 hours a day, and the energy is emitted as long-wave radiation due to the characteristic temperatures of the Earth and atmosphere. So you can consider as a stove, for example. If you were cooking, you'd have the burner turned on so it would heat up. The burner is like the Earth and the heat source. Be it gas or electric, it's like the Sun. When you're done cooking, you turn off the burner, but it stays hot for a long while, even after the heat source is gone. Turning off the burner is like the Sun going down, even though there is no more energy input. There is still energy output in the form in infrared radiation. The burner stays hot because it's still emitting the energy it absorbed earlier, just like the Earth. This time delay is sometimes called thermal inertia. Most of the energy emitted from the Earth's surface does not go directly out to space. This emitted energy is reabsorbed by clouds and by the gases in the atmosphere. Some of it gets redistributed by convection. Even more energy is released into the atmosphere through condensation. The majority of the energy is reabsorbed by the greenhouse gases such as methane, nitrous oxide, ozone, carbon dioxide, and water vapor. These gases constantly emit the Sun's energy back into the atmosphere and keep the Earth a habitable temperature. Eventually, most of the energy takes its way back out to space, and Earth energy balance is fairly well maintained. The energy that doesn't make its way out is responsible for global warming. On a global scale, the atmosphere circulation and weather is attempted to balance differences in solar energy that the Earth receives across the globe. Sunlight at the tropics is intense and direct, and a lot of heating of land, atmosphere and oceans occurs here. Sunlight in the polar region is weak and indirect and does not do a good job of heating up the region. Currents in winds and ocean water carry energy from the tropics towards the poles to help balance out the energy differences across the globe. So this graph shows the pole towards transport of energy with latitude in the atmosphere. So the red dashed and ocean, blue dashed and total solid. And the net radiation is positive, equator equator word of about 35 latitude and negative poleward of that latitude. And this requiring a poleward transport of energy to maintain radiative equilibrium at each latitude. Angular momentum is very important. Angular momentum is the product of a body's momentum of inertia, a measure of an object's resistance to change its rotation rate, and its angular velocity. In other words, it consists of the spin of a body. Angular momentum is conserved if there is no external torque or twisting motion about an axis. So hence, a spinning ice skater increases his or her rotation speed as the skater's arms are contracted towards the body closer to the axis of rotation. And the angular momentum is the product of the body's momentum of inertia. So it's very important term to remember. And in the tropics, the easterly trade winds gain westerly relative angular momentum from the Earth rotation, and in the mid-latitude westerlies, the winds lost this westerly angular momentum to the Earth by frictional drag of the air over and mountain ranges, so from the drag. Hence, there has to be a momentum transfer from low to middle and high latitude. Otherwise, the westerlies could cease within about 10 days. So basically, this means the the forces they cancel each other out, and they will have to change directions. So the wind was in opposite direction, they cancel each other out, and once they move the same direction, and the same momentum will make it move it faster. So meridional cells and zonal winds. This was first recognized by George Hadley in 1735, that air in the tropical trade winds flows towards the equator, and it turns to the right or left in the northern or southern hemisphere, due to the Earth rotation giving rise to northeasterly, southeasterly trades respectively. The air is heated at the equator and rises, moving northwards and southward aloft in the respective hemispheres. This air cools as it moves forward and sinks back to the surface about 30 latitudes, forming the subtropical high-pressure belts. These are permanent features that shift latitudinally and longitudinally with season. The meridional north to south thermally direct cells where warm air rises and cool air sinks are called Hadley cells. So in Hadley order. So this guy only did this part correct, and he came out with the single cell model. I will going to show that in another video about George Hadley in later videos about George Hadley, and also I will show about another guy called Ferrel cell. It's of course it's named after William Ferrel. So the thermally indirect north-south Ferrel cells so is mid-latitudes are very weak and of little consequence for transporting energy or momentum. In the mid 19th century, air motion in middle and high latitudes was identified to be mainly horizontal and to move in circular path around low and high pressure systems. But the significance of these motions for transporting energy and momentum was not recognized until the mid-20th century. In the 1920s, a defeat suggested that horizontal eddies, low and high pressure system could transport energy forward, but it was not established observably until the 1950s. When V.P. Stark and R.M. White analyzed newly available hemispheric wind and temperature data for the troposphere, they separated the forward transports into meridional cells, stationary planetary waves, and transient eddies, cyclones and anticyclones at the surface, and shortwave traveling waves aloft. They showed that in mid-latitudes, horizontal eddies accomplishes most of the forward transport of energy and angular momentum. This view is summarized in Eric Spermer's famous diagram, and the structure of both planetary and short-traveling waves favors forward transport of energy and momentum because of the waves are not symmetrical. Instead, they tilted towards the east, so that the poleward limb is longer than the eastward limb, allowing net energy and westerly angular momentum to be transported forward around the hemisphere. There are typically 2 to 4 almost stationary long waves and 6 to 12 short waves superimposed on them. Traveling eastward, the vertical Hadley cells in low latitudes and horizontal wave motions in middle and higher latitudes therefore accomplish the forward transport of energy and angular momentum in the atmosphere. The Hadley cells are more or less symmetrical about the equator at the equinoxes, but in the summer and winter seasons, a single cell is represented with a rising arm over the main heat source. With winter hemisphere cell is about 5 times stronger than the northern one, with cross-equatorial flow. However, most of the symmetry in the Asia sector, 40 to 150 east longitude east, due to the monsoon, and over the remainder of the global Hadley cells are present in both hemispheres. The vertical pattern of the polar transport sensible and latent heat imply that cyclones and anticyclones transfer the latent heat at low levels, and traveling waves transport the sensible heat at